Hello, my name is Stephen Borsich, and this is my presentation on the mutation of memes. Now, normally when we think of memes, we think of funny pictures of cats which are spread on the internet and we share with our friends and we get a good laugh out of. But in fact, this is something of a bastardization of the idea of what a meme is. And for the purposes of this video, I think it would be best if the viewer forgets any preconceived notion of what a meme is, as that would make understanding easier. The term meme originated from 1976 with the book The Selfish Gene, released by Richard Dawkins. And what he aimed to do in this chapter of the book was to say that ideas could be subject to natural selection in the same way that genes are. And he called this unit of which is acted on by natural selection, this unit of an idea which is acted on by natural selection, a meme. It comes from the Greek word mimeme, which means imitation. And it was shortened and made the sound similar to gene, so that it could be understood in a similar way. And I think to best understand how natural selection applies to ideas, it's best to get an understanding of what natural selection is. And really, natural selection is just a mathematical result of three premises, and these are heredity, competition, and mutation. And to better understand each of these premises, I think it's best to see how they apply as is naturally or is commonly accepted in the analysis of genes. So the first premise of heredity is present in genes because genes are copied in reproduction. All living things reproduce, and in this reproduction, the offspring share some of the parents' genetic code. The second prerequisite of competition exists for all organisms. It's unavoidable. We all must compete over limited resources, limited amount of food, limited amount of space, etc. The third prerequisite of mutation occurs for genetic organisms because the genetic copying, when genetic organisms reproduce, is not perfect. There can be sometimes just chemical errors in this process which result in offspring being slightly different from their parents. And sometimes these genetic mutations are beneficial, and so these beneficial mutations go into the system of competition and come out the other end on top, and so they're represented more in future generations. And this is the basis of the idea of natural selection as applied to living organisms. But the aim of this is to apply the same series of operations to ideas, or to say that they do apply to ideas. So to apply the theory of natural selection to ideas, or to memes, we must say that each of these three prerequisites occurs for the ideas. And the first prerequisite of heredity, we could easily say exists for ideas because ideas are reproduced. I am reproducing the idea of memes to you, the viewer, through this video. You see it, you hear it, it goes into your brain. And so that's like a transmission of the idea and a reproduction of it. If there first existed one copy in my brain, there now exists a copy in your brain. The second prerequisite of competition does exist for memes because the amount of ideas that you can hold in your head is limited. The amount of ideas that you can communicate is limited. And there's always an opportunity cost associated with that. By talking about memes, I'm not talking about light bulbs right now. And you're not listening to something about light bulbs. You're not learning about them. So that is competition occurring. You can only think about so many things in your life. And the third prerequisite of mutation is a bit more complicated and difficult to see, but it's sort of the goal of this research and hopefully this video to show that this does exist. Memes do mutate. So I think to best understand memes, we shouldn't look at our own interactions, like human interaction, because this can be complicated, because we are subject of it, so therefore we can be biased in understanding it. I think it's best to look into the natural world to gain an unbiased understanding of it all. And bird calls are memes. They are ideas which are held in the brains of the bird and transmitted from that bird to others. And so for this paper, I researched P.F. Jenkins' paper, Cultural Transmission of Song Patterns and Dialect Development in a Free Living Bird Population, which was released in 1978. It was a study that followed a population of saddleback birds, which existed on an isolated island in New Zealand. They were introduced there by humans intentionally in 1968, and they were studied for around 4 years, from 1971 to 1974, by this P.F. Jenkins guy. So these saddlebacks, which were on this island, had no natural predators there, which is important because that means that they were able to develop their population and exist as they would choose to naturally. And also they were sedentary creatures, which means that they didn't move around much. Once they established their territory, they wouldn't stray from that unless they were forced to. And because of these two factors, they were able to establish territories and stick to them, I guess, basically. And the way they avoided conflict, which would be mutually negative for both of the saddlebacks engaging in conflict over territory, if they did, was by songs. They would have territorial songs when they're at their home, so it would make it clear to other birds not to come around. And the songs were the subject of analysis for P.F. Jenkins. He studied maybe 20 pairs of birds throughout multiple seasons and analyzed the songs which they used. He studied up to 9 different patterns of song which were repeatedly used by these various birds. Each bird would have its own songs which or mark its territory, make it clear that it is that bird's territory. And the other birds would know to steer clear. And each bird could, in fact, learn up to 4 different patterns, according to Jenkins. And what's really interesting about this story, or this paper, is that young male saddleback birds learned songs from their environment, not from their father. So it wasn't genetic inheritance that they learned these songs from. It was memes. It was mimetic inheritance from the environment. Anyways, we can see on this picture is a sonogram of the call. These is like the patterns of the call, and these are different short clips of it by the AWG bird and the AGR bird, respectively. And we can watch a clip of the saddleback doing its call. So that's the bird, and noticeable at the end of this clip, it actually does the exact same call again. So I looked between those two clips. As far as I could tell, they were exactly the same. And this is of significant importance to these animals because that's like their source of identity. That's how they tell other saddlebacks which one they are and that they still exist there and that their territory isn't open. So here are some maps that were given by P.F. Jenkins. On the left here, you can see this is like a larger map of the island, and each one of these boxes represents an area in which a certain song was sung by the birds. These labels PH, NE, DC, SE, or whatever, they each represent a different bite of sound like you see here. I don't know exactly the labeling scheme, but so you can see sometimes they overlap. So some birds would have this PH and E pattern. They would have both patterns memorized, and they would recite them, PH and NE. And some birds would mix that with with the patterns of other territories, like this PH over here, or this PHZZ. You can see that down here is the ZZ category, and then up here is the PH, and so in here it's shared. And on the right here, you can see exactly why this differentiation is important. In the middle, the birds are labeled by these weird letters here: ARR, GWA, YR, AG, and such. So the ARR would have these three clips of song memorized, and that would differentiate it from all of its neighbors. So there wouldn't be any confusion, and they wouldn't overstep each other's boundaries. And so from this you can see that if you have a limited amount of songs in your repertoire, it gets increasingly difficult to have your own unique set of songs which marks your own territory. And Jenkins says that the most different clips of song he heard any one bird recite was 4. So there's a necessity for new songs to be created. And Jenkins actually witnessed this in young birds, which is very important to the subject of this essay. He noticed that some young birds would recite a song as was sung by an older bird in the same territory, but there would be a slight difference. And it's unknown why this difference would occur. It might have been that the bird misheard it, or that it just recited it differently by accident. But either way, sometimes these changes would occur, and this is what we could call the mutation of the meme of the bird song. And sometimes, of course, just by existing, a new song could be beneficial, because if you could remember one song instead of remembering 3 different songs to mark your own independent territory, that would be in your benefit. So by seeing that, we can apply the 3 heuristics of natural selection to bird calls. 1, heredity. The birds learn calls from hearing them and then repeating them. So a bird call that existed only in the brain of one bird can exist in the brains of other birds after those birds hear it, and then they can reproduce it again. The second heuristic, competition, exists because birds have a limited amount of songs that they can sing. According to P.F. Jenkins, it's 4. And mutation clearly exists in this example because the birds can adapt the songs, whether by accident or intentionally is unclear, but it's observable that this did occur, because birds would either drop a syllable or change a tone of an otherwise identical song to something that it heard in its environment. And these changes could be beneficial to both the bird and for the existence of the song in the future, right? By the bird singing the song has the potential to exist in the future as well. And so we can say that natural selection of memes can exist in humans, although it might be more complicated because we have much bigger brains than birds. That's not to say necessarily that in all cases how we process and relate to ideas is inherently different. We transmit ideas between each other, as I am doing now. If you read a book, the idea in the book is being reproduced in your brain. This happens on the internet. And competition of these ideas does exist. We have bigger brains than birds, but we can't remember everything. And we can only speak to each other about certain things and not other things. That's competition. Like, we have limited time to think about things and to relate things to other people. And I think mutation does exist for memes in humans because we frame things differently. We understand things differently. We can understand the same words spoken in a different way than somebody else might understand them. And I think that that is a mutation of the original meme being received based on differences in the brain of the receiver. That's it. That's my presentation. Thanks for watching.